So the last thing we're going to discuss with binary is the method for converting binary to and from decimal. Now, I tried to cram as much information into this single slide as I could so that you guys could either take a screenshot or reference the PDF and the slideshows in the future and have kind of a cheat sheet while you're practicing these. So let's do a quick conversion. We're going to start with the decimal number 78. So step one is to know your binary place values for a byte, and then just write them down at the top of your sheet of paper. Eventually these will come to you from memory, but for now, it'll definitely be helpful to write them down. Once we have all of that information written down, which you'll see on the left, is to subtract the largest binary value possible from that decimal number. And so knowing our placement values, we check the first on the left, which is the highest placement value, 128, and we know we can't subtract 128 from 78 without going negative, and we're not going to do that in networking or computing right now. So, since we can't use the value of 128, we place a 0 in that place value. So below step 2, you can see that under 128, I've placed a 0. That indicates that we're not counting that value. And so then we simply move from left to right until we can no longer subtract anything, meaning we have a remainder of 0. You can always subtract these numbers and result with a 0 remainder. So if you end up with anything other than 0 while doing these conversions, you'll know that you messed up the math somewhere along the way, and you can double check. Now, we know the next value is 64, and we can subtract that from 78. So step 3, we identify the 64, and so we can insert a 1 in our binary value below the 64. And so we subtract 64 from 78, giving us 14 remainder. And then we continue to work from that number. As we continue through our placement values and our goal to reach 0 remainder, we know we can't subtract 32 from 14 or 16 from 14. So let's place some zeros underneath those values. The next value we can subtract from our remainder is 8. So we subtract 8 from 14, and that results in 6. Continuing on, we can subtract 4, and we can subtract 2 from the remainder of 6 minus 4, which is 2. And now we have a remainder of 0. So any remaining bit values after we reach 0 will simply be 0. And so our number 78 translates in binary to 01001110. And if we were to write this out so we knew what numbering systems we were using, we would use a subscript. So we write 78 with the subscript 10 that lets everybody know that we're using the decimal numbering system on the left. And then we have our binary value 01001110 or 1110 with a subscript of 2, and that lets everybody know that we're using a base 2 system or binary. And the last thing we want to do is always to check our math. We always want to verify our information. So to do that, all we need to do is add up those binary values that show a 1. And so in this case, we have a 1 beneath the 2 placement, a 1 beneath the 4 placement, a 1 beneath the 8, and a 1 beneath the 64. So we simply tally up those values by adding them together, and that gives us 78. And so now we've double checked our math, and we've also learned how to convert back from binary to decimal. The crux to all of this is really knowing the placement values. And then all you need to do is follow the simple steps. With a little bit of practice, you should get the hang of this pretty quickly. It's really important that we understand the basic structure of binary, especially within the context of a byte, because we're using other numbering systems in networking that we'll be exposed to later that extend this a little bit. Numbering systems like hexadecimal, which is a base 16 numbering system. And I know that sounds a little bit daunting, but it's not too bad if you keep it in the context of binary. And we're almost always going to be working with values of 0 through 255 because we're almost always working with bytes. Now that we have done a simple conversion from decimal to binary, and we checked our math by doing the conversion from binary back to decimal, let's review. So, in today's lesson, we defined what binary is, what uses it, which is computers and networking devices, or anything that's digital in any sense. We only have representation of 0 or 1 for each placement value, so on or off. And then we reviewed decimal, just to kind of brush up on exactly how these two numbering systems relate. Then we covered the basic binary structure by establishing what the placement values were in our base 2 numbering system, which functions on the power or exponents of 2 rather than multiplications of 10 like in decimal. We delineated the difference between bits and bytes. Bits are an individual binary value, and bytes are 8 connected binary values. The byte range is 0 through 255. That's important and useful to remember as we move forward. Lastly, we covered the conversions from decimal to binary and, of course, binary to decimal. For decimal to binary, all we need to do is subtract the highest value available until the remainder is 0. So we just track down from left to right from our 128 all the way down to 1 until we end up with 0. Going from binary to decimal is simply tallying and adding up all of the placement values where we find a 1. So if we have just a 1 in the 64's place, we know we have the decimal value 64.